Hey, we have another problem from the UNSW Integration Bee 2019, problem 23. We have the integral of the square root of 1 plus 1 over x dx. And they give us this important condition, x is greater than 0. And I think that's actually going to help us out, because you'll notice you could have negative values in here and still not have negative in the square root. It's like if you plug the -5 in here, you'd still have a positive value inside the square root symbol. So for my first step, what I did here was I wrote my 1 as x over x and added these together. So then doing that, my integral looks like x plus 1 over x. And then from there, knowing that these are both positive, I can split my square root like this and write it this way. And then for the next step, what I wanted to do actually was a trig substitution. And it's not quite in the form that we're used to doing a trig substitution, but we can make it work if we do our substitution as square root of x equals tan of t. Because doing that, we'll notice that x equals tan squared t, and we'll get our derivative for our dx value. We're going to have 2 tan t, but then we need the chain rule. So the derivative of tan is going to be just secant squared t dt. And one thing I wanted to do before I continue and make the substitution is let's draw our triangle just to get a value for secant as well, so we have everything we need. So let's see, I'm going to draw my triangle. It's not the best triangle, but whatever. Okay, so if we have a triangle with the angle t, we're saying this ratio for tangent is square root of x over 1, so opposite over adjacent is going to be square root of x over 1. Then with the Pythagorean theorem, we can find our hypotenuse to be just the square root of x plus 1. You can confirm that if you do a squared plus b squared equals c squared, you get x plus 1 equals x plus 1. Again, because I know I'm going to do my value for secant, secant's going to be just hypotenuse over adjacent. So for our value for secant t, just square root of x plus 1. And then again, as we know x is greater than 0, we're not going to have any problem with our tangent value, having that positive value in the square root, and then here this is going to be positive as well, so we don't have to worry about any of that. Okay, so now I can make this substitution. And so for square root of x plus 1, we have this value, which is secant over here. So we're going to have secant t, square root of x is just tan t. And then for our dx, we found that, and it's going to be 2 tan t secant squared t dt. We're going to have cancellation of tan here. I'm going to bring my 2 out front. And then secant t times secant squared t is just secant cubed t dt. Okay, and then we'll integrate. We'll have our 2 out front. Now this is a pretty standard integral, so we'll use a formula for this. So this formula is going to be half secant t tan t plus half natural log absolute value secant t plus tan t. And then what I'm going to do now is we'll just use this 2 distributing in. We're going to cancel with our half. Okay, and we get a little simplification there. And then to finish it off, all we need to do is back substitute, but we already found our values for secant and tangent. So we'll put these back and see what we get. So for secant, we're going to have the square root of x plus 1. Tangent is going to be square root of x plus natural log. And then we'll have the same thing, square root of x plus 1 plus square root of x. We notice everything here is positive, so we can remove some absolute value signs there. Just write these as parentheses. And I think I'll take x times x plus 1 and write it as x squared plus x. Then I'll just add a plus c, and that's it, we're done. That's it, kind of a variation on a trig substitution problem. I like that one, so we'll stop it there. Thanks for watching, everyone. Have a great day.